I
use my phone then.
have a bright fluorescent. It shows up on the screen.
Okay. That's all right. Pardon?
Said she said there was a script.
Oh, she might have taken it. We were taking it to get pronunciations on Stephanie. Yeah, so I'm sure Kara has it.
Yeah, she seems to be holding something in the bag.
Yep. But there's no good light here. I assume they do it so that it can be dark behind us.
Probably.
So I always keep this with me.
Just in case, right?
Yeah, and I have really good eyes, but this is. And is that your portfolio?
Yeah, it's my.
Will you take it with you?
Yep.
Because I have to go 3 wide on the first one because it my lines go on 3 pages.
Mm-hmm. Yeah. No.
And I don't want to grab your secret notes.
Well,
in the process, nothing good in there.
I don't know what this is.
Oh, those are mine.
Okay.
Those are questions. You know what? Let's put those down on just so they don't get lost. Thank you. Just put them. Yep, perfect. Those are the questions I have. In fact, maybe I better read them. Make sure I can read them. Okay, that's a good question. Make sure you have a question. You got it? You only need page 1.
Yeah.
And you should have a question. Come up with a question in case we're slow on questions. Well, we'll listen and then just develop something. You know, how can universities be a part of something? We just need to support.
Good morning. My name is Denise Smith. I'm the Provost and Vice President of Academic Affairs here at Owens Community College. It's my pleasure to welcome you to Owens. Today's program, Technology Takes the Wheel, was born from an idea in 2018 from a collaboration between AAA and the University of Toledo's Department of Engineering, exploring autonomous vehicles and the next wave of transportation. Today, we are recharging this seminar series to explore electric vehicles. Our moderator for today has been part of the seminars from the beginning. Lisa Guyton is a reporter with WTVG 13 ABC. She has been a member of the news team at Channel 13 for 21 years. She is a respected journalist and native to the Toledo area. Please welcome Lisa Guyton.
Good morning, everyone, and thank you, Dr. Smith. I am very excited to be here. This has been such an important series since the beginning because, as you know, the automotive industry certainly drives so much of our region. And, of course, it is making headlines again as we speak. So what a wonderful series, and all the people who made this happen in the very beginning had a lot of foresight, and so I am grateful to continue to be part of this. I'd like to recognize our sponsors for today's event. Our host, this absolutely beautiful facility, Owens Community College, also the Toledo Metropolitan Area Council of Governments, TMACOG, and AAA. Now, a little known fact about electric vehicles is that the first crude electric vehicle was developed in 1832 by Robert Anderson. But even with its early start, by 1912, of course, the mass-produced gas-powered vehicles, the Model T, took over the market. And by the 1990s, the technology improved and gas prices rose and made electric vehicles popular again. So a little bit interesting history tidbit there. The technology continues to improve and infrastructures are further developed to support EVs, and our experts are going to tell us about infrastructure to support EVs, the technology advancements, and safety. And just a quick housekeeping message for all of you. We will have a time for questions at the end of our speakers during the panel discussion. Now, there are cards available if you'd like to turn in your questions, or you are free to just stand up at the mic and ask a question during the panel discussion. Our first speaker is Ryan Martinez, Manager of Market Customer Analysis for First Energy Corp. Ryan has 15 years of experience in the electric utility industry, including wholesale marketing and forecasting, rate marketing, default service auctions, portfolio management, finance, and business strategy. Now, most recently, Mr. Martinez has been involved in supporting and informing on energy solutions for end-use customers and policies to maximize customer benefits while driving regulated electric utility initiatives for electrification affordable and sustainable. Now, this includes the tracking and analysis of the adoption of electric vehicles, build-out of the electric vehicle supply equipment network, and program initiatives that support each and every one of these. Through this experience, he has gained enough of an appreciation for EVs that the Audi 6-speed manual transmission was traded in for a Tesla. Welcome, Ryan Martinez.
Thank you very much for that introduction. My name is Ryan Martinez, and I work for the electrification strategy team at First Energy. Gonna get through to my slides here. And our group, as was mentioned, is we're responsible for tracking the progression of transportation electrification in our service territory, which includes 10 utilities across the states of Ohio, Pennsylvania, New Jersey, Maryland, and West Virginia. And we are also responsible for figuring out how transportation electrification fits into our overall policy, strategy, and planning process. So as part of this, my team does a lot of customer outreach. And in doing these events, like we'll do auto shows, trade shows, state fairs, boot camps, things of those nature. And we get to engage with a lot of our customers and to get kind of feedbacks about their thoughts on EVs. And naturally, since many of these people attend these types of shows and they decide to walk up and engage with their electric utility, a lot of them are very enthusiastic. You know, they either are very excited about it, or they you know, they already have switched over to an electric vehicle and they want to share that experience and talk about it. But there are a lot of people that we will engage with that are a little bit more hesitant and reserved about it. And that second bucket of customers, the ones that really aren't very keen on EVs, I find the feedback that they provide very, very informative. And so one of the things that is kind of the most common things that they talk about for why they're not very excited about electric vehicles all usually revolves around vehicle charging, whether it's range anxiety, whether it's the location of the chargers and the distance from them, or the availability and proliferation of them, or when it comes down to just confusion about the technology. How do I even charge it? Or charge times of like, it takes so much longer than it would to just fuel up the car. So one thing that I do want to talk about is just charging in general. And at the panel discussion, I'm happy to address all the different things that the utilities are doing to help with the electrification and the adoption of electric vehicles. But because of the reasons I mentioned, I want this presentation to be focused more on EV charging. So the Edison Electric Institute, which is the kind of representative for investor-owned utilities in the United States, they have identified that there is a large need for charging infrastructure network. There is, they forecast that there's going to be over 26 million vehicles that are electric on the road by 2030. And 2030, the annual vehicle sales are going to be over 5.5 million. So that's going to be a lot of vehicles that's going to need a lot of charging to accommodate. And they estimate that they're going to need nearly 13 million chargers in the United States to do so. And of those 13 million chargers, they're expecting that they're going to need about 150,000 DC fast chargers. So that's a huge infrastructure need to be able to support EVs. But the good news is that there are initiatives that are out there that are helping to address that. The Infrastructure Investment and Jobs Act, or IIJA, is currently investing over $18 billion into transportation electrification across 4 programs. So $7.5 billion of that is related to 2 specific programs that are there to mainly address the infrastructure. And these are the NEVI, or the National Electric Vehicle Infrastructure Formula Grant Program, and the CFI, or the Charging Fueling Infrastructure Discretionary Grant Programs. The NEVI is assigned $5 billion to address charging infrastructure along the major travel corridors, and I'll get into that in a bit. And the CFI is meant to really address the community charging. So we're talking urban, rural communities, Justice 40, and the like. So there's a lot of investment that is out there to be able to address this charging need. I have some graphics here on the right too. These are sourced from the Bloomberg NEF, which is the net energy forecast, and their electric vehicle outlook paper that they put out annually. And you can see there that by 2030, globally speaking, but maybe like 2035, they're expecting over half of all vehicle sales globally to be all electric. And by 2040, we're going to be looking at maybe about 60% or 40% of the vehicles on the road also being all electric. So there are a lot of large investment firms and a lot of large research firms out there that truly believe that the transportation electrification is coming, and this growth is going to be accelerating. So a little more detail on the NEVI program. The goal of NEVI, and then this is kind of like the boilerplate like headline that they have, is that they want to have 500,000 fast charging stations across the United States that are located along what they call alternative fuel corridors, and these are mainly interstate highways or other major highways that are main arteries for interstate travel. And their goal is that along these corridors, they don't want you to have more than 50 miles between charging locations. So the overall goal of this program is to make sure that if you're going to be traveling a long distance in an EV, that you're always going to have access to high-speed charging, so that way you will have the infrastructure to travel across the country and do so. I have a map up here of the grants that were awarded in Ohio, and that's more than $18 million of investment in the first round of funding for 27 charging locations in the state of Ohio. And that was matched with nearly $6 million of private sector investment for these sites. So these are not free to the developers. They are putting their own kind of skin in the game, so to speak, for building out this infrastructure. Future rounds will address further gaps in the state. And one thing that I wanted to point out, since we're in Perrysburg here, is that there is a site that was awarded right there on I-75 at State Route 186, or Lexus Road. So this is having investment right to this community, and there's likelihood that there's going to be more coming with future rounds of funding. And then the CFI grants, they address the rural and urban communities and Justice 40. Now, both programs have provisions within them that allow CFI to fund kind of some of the travel corridors programs, and NEVI, if there's excess funds there, and they have addressed all the gaps in the travel corridors. They have provisions in being able to use that for community charging as well. But for the most part, NEVI is meant to address interstate travel, and CFI is meant to address community charging. So, let's see. So these first couple of slides addressed the public charging, but I kind of want to take a step back now and talk about the basics. So really there are three types of charging. The first is AC level 1 charging, or L1 charging. And this is what you think of with a normal outlet plug, the same thing that you would like plug your phone into, or a hair dryer. And the cars can actually charge off of that. Now they're a slower charge. We're talking usually about 1 to 2 kilowatts of power, and it's running off of 120 volt. So generally you only get about 3 to 5 miles worth of range from the car per hour. So it is a trickle charge, but it is still a valid method of charging the vehicle. The second is AC level 2, or L2 charging. This is AC 240 volt charging that is done anywhere from 4 to about 19 kilowatts. Typically, it's around 7 kilowatts of power used to charge the vehicle. This is what we think of destination charging. A lot of times that they'll have these at grocery stores or workplaces, and it's also what people will usually install in their homes, in the garage for home charging solutions. Now the beauty of this is that if with the cars, they're generally parked a large percentage of the time, and that allows for the car to get a full charge overnight. So with good access to level 2 charging, you really don't need anything else. It is very sufficient given the amount of idle time that the vehicles usually have. And the third type, and this is the type that gets the most focused, is DC fast charging. Now, this is what people are used to seeing with the Tesla superchargers, or like a lot of the stuff that's going on with the NEVI investment about large charging stations along the highways. And these are 480 volt, or for certain model vehicles, they can charge at 800 volt. And they range anywhere from 50 kilowatts to about 350 kilowatts for passenger vehicles, vehicles, and they're currently researching doing up to megawatt charging for long-duty haul vehicles. But for most part, the most popular charger on the road is about 150 kilowatts, and that pulls generally around like 400 amps of power. So it gets a lot of the focus because it really is what most resembles what people are used to with what they think of fueling the vehicle, which is the gas pump. But the reality is, it is the type of charging that gets used the least. And people have a kind of hard time getting their head around that because they have this relationship with fueling the vehicle that is, okay, it gets low, I have to stop to get gas, I put in gas, and I'm good to go. But really, fueling an EV is a lot more akin to charging your phone than it is to actually filling your car with gas. So a big thing that we're trying with our customer education is getting to people to understand that we really need to rethink the fueling paradigm. The most the anxiety that people have, like I said, with fueling the vehicles is, with adopting EVs is around range anxiety. So they say, well, what if a charger's 100 miles away and I'm low battery? I don't want to have to wait 20 minutes to charge. But the reality is that over 80% of charging for your electric vehicle is done at home. And when you're able to do so, if you have access to charging at your residence, it's pretty much akin to leaving your house every day with 3/4 of a tank of gas. And if you go and you drive, how often are you driving where you're going to be using more than that in a single day, and then where you have the ability to go home, and then the next morning when you wake up and you have to use your vehicle again, you're back to that same 3/4 tank of gas level. So it's really about getting people to understand that it's not this relationship that we have with fueling now about going to the gas station, filling up, and running it to empty. It's about the basics of being able to charge the vehicle when you're not using it, and being able to do that all the time. So the exception to this too is if you're doing long distance travel. So if you are traveling, I'd say more than about 250 miles in a single day, you are going to need to stop and charge. But practically speaking, what that means is if you're the type of person, if you drive and you take your stops like a NASCAR pit stop, it's going to cost you about an hour per 500 miles. So really what you're talking about is if you're having an 8.5 hour drive, maybe that's a 9.5 hour drive. And I promise you, it's really not as bad as it seems. But that's the one disadvantage with the range, is at least with the current technology that we have right now. Additional note too is that the fueling is actually far more affordable. We're talking about 5 cents per mile versus 12 cents per mile for gas cars. So there's major fuel savings there. But one thing I do want to address, and this is something that a lot of groups are trying to working to address, is the fueling needs for multi-unit dwellings. So if you do live in an apartment and you do not have access to a garage or a carport, then it becomes much more pertinent that you have access to charging at some of your regular stops, like your grocery store, your workplace, or other public charging infrastructure, to be able to accommodate, at least until we have the solutions to be able to penetrate this market and provide more reliable charging at these multi-unit dwellings. So just going to kind of recap with some of my key takeaways here. The overwhelming majority of charging is done at home. You might need to rely on some public charging infrastructure if you're going to be traveling long distances, like more than 200 miles. And then we have, over tens of billions of dollars of investment by the federal government and much more by the private sector that are investing into the public charging network to be able to provide more reliable public charging when you don't have access to it at home or if you're taking these trips. I wanted to highlight a couple of things that are happening. Hilton is partnering to join the supercharging network, so there's going to be more access to charging at hotels. Ford dealerships and many other auto dealerships have partnered where if they want to be able to sell their electric vehicles, they're going to have the electric charging infrastructure on site. So these are just some of the programs that are happening, and a lot of large businesses are under pressure to be able to put this charging infrastructure into place. Fueling costs for EVs are cheaper. And then the last thing, I know I didn't really talk about this, but it's another question we get a lot, which is the grid ready for this? Can we handle it? And right now, in the state of Ohio, we have about 0.6% of registered vehicles are electric. Could we accommodate 100% electric vehicles tomorrow? Absolutely not. But if you remember from my earlier slide, we have about 15 to 20 years before we're getting into the territory where 20, maybe 30% of the vehicles on the road are electric. So we have a lot of time, and this is a very important initiative that we're actively working at addressing for how to best plan our distribution and transmission systems to accommodate for the EV adoption. So we have plenty of time to build the resiliency that we're going to need to be able to accommodate it when that time comes. Even if we have 100% electric vehicle sales tomorrow, the average lifespan of a vehicle on the road is about 10 years. So it's going to be about 10, 15 years before you're talking about 80% of the vehicles on the road being electric, just by sheer attrition. So there's and we're not there with 100% electric vehicle sales, not even close. So there'll be ample time to be able to plan the system out accordingly. And then lastly, I just have a couple resources that are out there. So First Energy, we do have a consumer education site called Choose EV as part of our EV-driven program, and that's up there. So there's information about EVs, EV models. You could calculate how much you would save on fuel, and there's some other great information there. There's the Alternative Fuel Data Center, which is a part of the Department of Energy, and they have great resources there as well. They have, I would say, probably one of the best charging station locators that are available, so I highly recommend that one. The Joint Office of Energy and Transportation is kind of like the program that's heading up a lot of the federal programs on behalf of the Federal Highway Administration for programs like NEVI and the CFI, but they have some other great publications that are referenced there on their Drive Electric site. And then finally, the US EPA has a great myth-busting page regarding EVs and some of the common misconceptions about them. So just some resources I want to leave you with. Thank you very much.
Thank you, Ryan. And our next speaker is Dr. Sandrine Mubenga, Assistant Professor at the Engineering Technology Department at the University of Toledo, where she received her bachelor's, master's, and doctorate degrees in electrical engineering with honors. Her research areas include battery management systems, electric vehicles, and renewable energy systems. Her battery research won the 2018 IEEE National Aerospace and Electronics Conference Best Poster Award in the US, while her hybrid electric vehicle research won the 2008 University of Toledo EECS Department Most Outstanding Thesis Award. Prior to this role, Sandrine was the manager of electrical engineering at UT, where she helped manage a $65 million budget. She is a registered professional engineer in the state of Ohio. Welcome.
Thank you so much for this nice introduction, Lisa. Hello, everybody. It's nice to meet you today. I'm Dr. Sandrine Mubenga from the University of Toledo. So today, let's start talking about the big picture, about the world. And the big picture in terms of energy in the US has not really changed this past year. So back in 2008, we conducted research where, at that point, this is the energy usage in the US, and 85% of the electricity and the energy we were using was coming from fossil fuels. The only problem is when we use fossil fuels, in order to use them, we need to burn them. And by burning them, they emit greenhouse gas, such as CO, CO2, NOx, SOx, particulate matter. And those greenhouse gases affect public health. It is estimated that thousands of Americans are dying every year because of pollution. So in the transportation sector, about 29% of that energy was used just for the transportation sector. So even though it was the second sector in terms of energy consumption, it was the highest sector to emit greenhouse gas. 34% of the greenhouse gases in the US came from the transportation sector. So in terms of climate change, in order to find a solution to climate change, people turn to EVs because EVs have no emission. When you have an electric vehicle, there's no emission. The only problem, like Ryan mentioned earlier, is that most people have what is called range anxiety. They get scared of being stuck because the battery is not fully charged. So in order to reduce that range anxiety, the research we conducted at the University of Toledo was looking at ways to increase the driving range of EVs. So what we did, we basically incorporated a fuel cell to an EV so that it could run off hydrogen. So the way the fuel cell works, it's an electrochemical device that's going to take the hydrogen from the tank, mix it with oxygen, and produce electricity and water. So we made up a fuel cell hybrid vehicle here, and the advantage of the fuel cell hybrid vehicle is that there are no emissions and it has an increased range. Now, the only way we could do that so that we could combat climate change was that the hydrogen had to be what we called green hydrogen. It had to come from a renewable source. So what we did, we produced hydrogen at the University of Toledo using solar power. We used a 6 kilowatt array that is located on Dorr Street, if you are familiar with the University of Toledo. And that 6 kilowatt hour solar array was providing power to an electrolyzer. An electrolyzer is just a machine that breaks down the water into hydrogen and oxygen, right? Because water is H2O. So through electrolysis, you can break down the water into hydrogen and oxygen. And then what we were doing, we were taking that hydrogen and pumping it into the fuel cell hybrid vehicle. So this type of research that we are conducting at the University of Toledo was to prove what is called the hydrogen economy, or basically a full cycle of hydrogen. So producing hydrogen and then using it in the fuel cell hybrid vehicle. So on the next slide, this is a picture of me charging. I was basically fueling hydrogen, filling the tank with hydrogen into that fuel cell hybrid vehicle. And that was back in 2008. So there's been quite a few projects with a fuel cell hybrid vehicle. The first one was the GEM fuel cell hybrid vehicle that was done by Dr. Stewart and Mustafa Barakat. The second project was the one I worked on for my master thesis. Here I was doing my master thesis. It was the Chronosport fuel cell vehicle, hybrid vehicle. And of course, we had to come up with the hydrogen generating station. So that was also a project that we did, the solar-powered hydrogen generating station. and I worked on this project with Dr. Stewart. So working on all those projects and the renewable energy, so meaning the solar power associated with it, we could see that in the future, as Ryan mentioned earlier, EVs, the adoption of EV is a growing trend. So that means that in a few years, it's very important to think about what happens to those EV batteries. When you have an EV battery, when the capacity of the battery reaches 70 to 80% of the original capacity, that battery is deemed to be not useful for automotive application. So basically, at that point, your dealership will tell you to change your battery in your EV. So that may cause a huge problem in terms of waste management issues in the future. In fact, it also gives us an opportunity for second life EV battery market. So second life battery can be used for energy storage. And by 2030, the second life battery capacity is expected to reach about 275 gigawatt hour, according to ID Tech. So in order to use the batteries in their second life, meaning after they reach 70% of the original capacity, we need to have what we call a good battery management system. And part of the battery management system that will do that is called the equalizer. In this picture here, I'm showing a test that was done on 48 batteries. These are lithium-ion batteries, and you have all type of chemistry in the lithium-ion batteries. The one that was tested here is the NMC. NMC stands for nickel, manganese, and cobalt. Those are the lithium-ion batteries that are mostly used for automotive application. 48 batteries were tested, and if you can see here, the vertical axis shows you the capacity of the battery in amp hour. So the capacity is 1.8, the maximal capacity of the battery. And the horizontal axis shows you the cycles. The cycles is what we use to determine the longevity of a battery. The more you use the battery, the more cycles. You have charging and discharging cycles. So this is the longevity of your battery. So as you can see here, when we get right at the knee, that battery has reached about 70% of its original capacity. And at that point, you can see a huge discrepancy when it comes to the capacity of the remaining battery. And that's one of the reasons why, after they reach that threshold of 70 to 80%, those batteries are considered end of life for automotive application, but they can be reused for storage application, other applications that don't require as much power. So in terms of sustainability, I used to be a manager of electrical engineering at the University of Toledo, and my role was to do energy management for UT. So I did that for 5 years, and we had about 119 buildings at the time, 8 million square feet, 22,000 students. And I managed $65 million for energy. That's just what the University of Toledo spent over 5 years for energy, meaning electricity, water, gas. And we were doing everything based on sustainability. So sustainability has what we call the 3 R of sustainability. You have reduce, reuse, and recycle. So as part of our research, we were part of the National Science Foundation I-Corp at Ohio and I-Corp Akron program, and we ended up talking to about 104 stakeholders in the battery ecosystem to find out what is your pain, what are you trying to prevent in the future, where are we going with EV batteries. And what we learned from those 104 interviews is that used EVs offer a huge opportunity in their second life. So In terms of the battery, the EV batteries currently, in order to be sustainable, if we were to apply the 3R, what people are doing first to reduce the waste is basically through design. So right now people are talking about glass battery or solid-state battery. Dr. Goodenough, who invented the lithium-ion battery and who recently passed away, he was I think he was 103 years old when he passed away recently in Texas, was working with, on a glass battery. So instead of having a liquid electrolyte inside the battery, they wanted to have something solid. Solid battery. And then there are some more research on a flow battery, and then some companies are trying to use nanotechnology also. In terms of the reuse, this is where we are focusing our research. We can change the application going from mobile application, which is your automotive application, to a stationary application. And by doing so, if you look at the past slide, we can increase the longevity of the battery. We can use it longer. But in order to do that, it requires an appropriate battery management system or a good equalizer, because the equalizer is the part of the battery management system that's going to equalize the charges. And of course, we need some good design tool. Finally, in terms of recycle, we still have a lot to do when it comes to recycling lithium-ion battery. Currently, according to the EPA, about 99% of lead-acid batteries are recycled in the US. However, we only have less than 5% for lithium-ion battery. And that is because the chemical component of lithium-ion battery are what you call rare earth minerals. They are heavy metal. In fact, the EPA considers lithium-ion battery as hazardous material. So you cannot mix them with your recycling bin. If you have lithium-ion battery, you need to tape each electrode, and then you have to call a specific recycler for lithium-ion battery. You cannot mix it with your recycling stream for recycling. It's considered hazardous. So in terms of the second life battery, the market is expected to grow tremendously. So by 2030, we expect to have about 6 million EV battery to be retired every year, starting from 2030. And then that is equal to about 275 gigawatt hour of capacity that will be available from those second life EV batteries. So the market, in fact, for second life EV battery is estimated to be around $7 billion by 2033. So there's a huge opportunity over there. So let's talk about the lithium-ion battery circular economy. The circular economy is, in terms of sustainability, what we want to reach. Currently, this is the path we are on. The raw minerals are mined in different parts of the world, and the raw mineral gets manufactured into battery. And once it's manufactured, it is incorporated into the EVs, and the EVs are being used. Now, as I explained to you, over 95% of those batteries end up in the waste, as waste. But there are other alternatives. There are some companies right now who do repurposing. So basically, they take your old EV battery, then they test it. They test each cell. They sort it so that they know the capacity of each cell. And then they build second life EV batteries for stationary energy storage. And they do pack level assembly. So that's an alternate path, but it's not quite very common yet. Another path would be to, once the EV has reached the end of its life, when the battery inside the EV has reached the end of the life, the dealership would basically retrieve. That's what some automotive companies do, such as Tesla. They get your old EV battery. And what they do, they disassemble the battery. So the battery is made up of different cells, and then they test the cells, then they reassemble it. And at this point, there is an opportunity for a second operation of the battery. This green path here is what we would like to happen. This is not existing right now. So the operation for your EV battery that comes from your used EV battery can happen in 3 sectors. You can use your second life battery into other lower power electromobility application. So that's a possibility. You can also use them for stationary energy storage. And finally, you can also use them for extending the life in a new EV. So this would be a path. This is only possible if you have a good battery management system. Another option, what people are looking at right now is once the pack is disassembled, it can be recycled. And then when we recycle the material, the advantage is that we can recuperate that raw material that is so hard to get in the first place and use it to produce more batteries. So the battery itself consists of cells that are connected in series. And each cell has a specific voltage associated with it. So the pack voltage, when you have a battery pack, the pack voltage is just the sum of the voltage of each cell. So we say that the battery pack is balanced if all the cells have the same level of voltage, or what we call the state of charge. So if the state of charge in all the cells is the same, then we say that the battery pack is balanced. If the cell voltage are not equal, we say that there is a cell imbalance, and that cell imbalance is known as the weak cell issue. And why do we care about the weak cell issue? Well, we care about the weak cell issue because it causes 4 big problems when using batteries. The first one is that it's going to increase your safety risk. Then it's going to shorten the longevity of your battery. Third, when you have a weak cell in the pack, it's going to cause your battery pack to charge incompletely. And finally, when you discharge your battery, you are not going to fully discharge your battery. Let me explain this better. When a typical lithium-ion cell voltage is going to operate between 2.8 volt and 4.2 volt. So if the voltage is greater than 4.35 volt, you charge the voltage at a voltage greater than 4.35 volt, it's going to go through thermal runaway. And this is a picture of thermal runaway, so it gets hot. It releases some hydrogen and some gas. And if nothing is done, at this point, it's going to catch fire. So this is what we have seen happen when lithium-ion battery catch fire. It's because they go through thermal runaway. So the second issue that is caused by the weak cell is that it's going to shorten your battery longevity. So if the charging voltage is greater than the rated maximum voltage for your battery, your weak cell is going to charge faster. So it's going to degrade faster. So as a result, your weak cell will degrade faster, and it will cause your entire battery pack to have a shorter life because of the weak cell. So I'll give you an example with numbers. So if, for instance, you are charging at 4.25 volt instead of the specified 4.2 volt, you are actually increasing the degradation rate by 30%. So you may say, okay, it's only 0.05, I'm fine, but actually you are degrading it faster by 30%. So this cell degradation is causing the entire battery pack to degrade faster. The next issue with the weak cell is the incomplete charging of the battery. When you charge a battery, the weak cell is going to charge faster. And as a result, if the weak cell charges faster, there is a protection circuit inside the battery to prevent overvoltage. So your weak cell is going to reach overvoltage, and it's going to trigger the protection of the circuit, and it's going to stop charging the pack. So you end up with a pack that is incompletely charged, and I'm going to show that to you here. I'm closing the switch here. So these are the good cells. This is my weak cell, which is going to charge faster. I have current flowing, and I'm charging all the cells, but my weak cell is charging faster. I'm reaching the 4.2 volt limit. Therefore, my overprotection circuit opened the system. And as you can see here, my weak cell is fully charged, but look at the rest of the pack. It's not fully charged, okay? That's because of the weak cell. Another issue because of the weak cell is that it's going to reduce the battery discharge capacity. And why do we care about the battery discharge capacity? Is because as consumer, when we plug our electronic equipment or light bulb or any type of electrical load to the battery bank, we are powering our equipment during the discharge cycle. So during the discharge cycle, what happens is that the weak cell is going to discharge faster than the other cell. And as a result, your weak cell is going to reach the lower limit, and it will trigger the undervoltage protection of the circuit, which will break the circuit open and stop the discharge. So you can no longer use your equipment because of that weak cell. So this is an illustration of what happens. I'm closing the switch here, powering, so my current is flowing, turning on my light bulb, and now I'm discharging. These are the good cells, this is the weak cell. My weak cell reaches the lower limit before, and as a result, because it reaches the lower limit before everyone else, my switch here is going to open, and at this point, I can no longer use my load, right? So what you have here is that your weak cell is depleted, but look at the rest of the good cells. You still have capacity that is trapped inside the battery pack and that you cannot use because of that weak cell. So there is a piece of equipment to solve that problem of the weak cell. There is a piece of equipment that is called an equalizer that is going to make the state of charge equal, the voltage level equal in all the cells. The equalizer is part of the battery management system, and we have three types of equalizer. We have the passive equalizer, the active equalizer, and the bilevel equalizer. So this is the passive equalizer, which is very common. It costs about $1 per cell, but it has a very poor performance. The way it works with the passive equalizer is that it can only dissipate charge during the charging. You know how the weak cell charges faster? In order to make the charge equal, the passive equalizer is just going to dissipate the extra charge. So poor performance, poor efficiency. The second type of equalizer are what we call the active equalizer, and this one, you have a ton of architecture that are available, and they are very performant. The efficiency is close to, it's over 90% efficient. The only problem is that it has a good efficiency, however, it's very expensive. It costs about $10 per cell. So in order to solve that problem, we wanted something that was affordable, that did not cost a lot of money, and that had a good performance. So in my lab, we developed the bilevel equalizer, which is a hybrid equalizer that is going to have the performance of an active equalizer. So it has a high performance, but the cost is close to the passive equalizer. The cost is about $1.30 per cell. So we're trying to get, we got the best of both worlds. So like I mentioned, there's a lot of research going on in the battery management system to improve the life and the performance of the battery, making sure the charge and voltage are equally distributed. Because if you have overcharged cell, it may create thermal runaway or fire. So what we've done here, we have shown you here what is important and how it's important to have a good equalizer for second life application. Here we have the capacity of the battery. It goes from all the way to 100% capacity of the battery. And here you have the number of charge-discharge cycles. So this is the longevity of the battery. And what we are doing here, we are comparing the performance or the longevity of batteries under different equalizer. So A is showing you what happens if we had a passive equalizer, B is showing you what happens if we have a bi-level equalizer, and C is showing you what happens if we have an active equalizer. So your normal battery, so from here, from 100% to 80%, this area of the curve is called the EV operation. And if you look, it doesn't really matter what equalizer you use at this point. The performance is very similar during EV operation. At this point, it has reached end of life for the automotive industry. So we enter the second life application. In the second life application, it is very important to have a good equalizer, because if you were to use a passive equalizer, instead of 1,000 cycles, you could get to about 1,300 cycles. So you would add about 300 cycles of life. If you have the bi-level equalizer, instead of 1,000 cycles, you could have about 1,600 cycles. So you would have 600 cycles to the life of the pack. And if you have an active equalizer, you can go all the way to 1,800 cycles. So you would add 800 cycles to the life. So the difference here, in addition to the performance, is the cost. A is $1 per cell, B is $1.30 per cell, and C is $10 per cell. So when we were doing those interviews, talking to 104 stakeholders, they said that they are aware of the weak cell issue, but they are basically not buying the active equalizer because $10 per cell is too much. So that's why we came up with the bi-level equalizer. Now, next, now that we had the equalizer, it was very important to know when I have my cells, and I'm going to use this here. These are the cells. Let's assume they are equal sizes, and these are the water level is the charges in the cell. When I transfer charges between the cell, when I use an equalizer, other than the passive cannot transfer charges. If I use an active equalizer or a bi-level equalizer, I'm transferring charges from the good cell to the weak cell in order to make it equal. I need to find a way to measure the charge transfer efficiency, because what happens if I'm trying to transfer charges but everything falls in between? If the efficiency is poor, there is no point in having an equalizer. So it's important to know how to measure the charge transfer efficiency. And that's why we came up with the efficiency measuring apparatus. This is a picture of the efficiency measuring apparatus in our lab at the University of Toledo. This is the efficiency measuring apparatus for a 4-cell section here. And this section was about 14.4 volt. And this is the DC power supply and all other equipment in the lab. So we developed that technology, and we have a provisional patent on it. And what we did, we tested several batteries using the efficiency measuring apparatus. So there was, for instance, one of the batteries that we tested at 12,000 hertz was able to provide us with an efficiency of 76% as measured with the efficiency measuring apparatus. These are the different tests that were done. So this is what we call a single cell here, and with different load, and this is the 4th cell here. So at 14.4 volt, we had about 76% efficiency. And the next one here is if you have a 6-cell section. So that's one way you can use to measure the transfer efficiency. The other ways that exist to measure the transfer efficiency are the ultra-fast current voltage measurement and the electrically detected magnetic resonance. These are all ways that you can use to measure the efficiency the transfer charge efficiency. So, to summarize here, we have a great opportunity with EVs. We have to think about the waste management, or we have to think on how we can create that circular economy for lithium-ion battery, because we are not there yet. And in the future, we have numbers that Ryan showed, you know, that huge growth when it comes to electric vehicle. We have to think already about providing that path for reusing those lithium-ion battery, and that can only be done if we have a good battery management system and if we have a good equalizer in it. So thank you for listening. My name is Dr. Mubenga.
Thank you so much. And our next speaker is Bob Kazmierzak, Director for Approved Auto Repair and Club-Owned Repair with AAA. He has been in the automotive service and repair industry for the last 39 years, focusing in the areas of management and service management of auto repair facilities. He has been with AAA since 2004 and accepted the role of Director of Automotive Products and Service Development in 2016. His roles include the oversight of the approved auto repair program in the AAA Club Alliance in 13 states and the contractor service network in the states of Ohio, Kentucky, Indiana, West Virginia, Kansas, Oklahoma, and South Dakota. He also works on new projects with the AAA National Automotive Engineering Team. He serves on a number of boards, including Owens Community College Automotive Advisory Board, Penta Vocational School Automotive Advisory Board, and Drive Ohio Workforce Development Team. Welcome, Bob.
Thank you. And Lisa, thank you for that introduction. Well, good afternoon, everyone. And again, thanks to all of our presenters today and all of you for taking part in this presentation today. So I want to share with you some of what is AAA doing in this space with EVs. And I want to keep in mind other technology, right? So I don't want to forget about ADAS technology, so automated driver assist technology. So basically what we do today is we work to understand the new technology, we test, we verify, and then we publish the data. You know, our goal is to share our information with the public, safety groups, OEMs, manufacturers, engineers, students, and any others who are interested. We also work to understand what we need to do to service the vehicles from the roadside to the shop. So that's one of our main goals, is taking care of our members. One of the studies that I wanted to share with you that we just recently completed was our EV range as a function of external temperature. So previous EV range testing found that 5 popular EVs of the time, HVAC use at 20 degrees Fahrenheit resulted in a 41% decrease of combined driving range on average. HVAC use at 95 degrees resulted in a 17% decrease of combined driving range on average. And then without AC use, combined driving range reductions were modest. Ambient temperature of 20 degrees resulted in a 12% decrease of combined driving range on average, and ambient temperature of 95 degrees resulted in a 4% decrease of combined driving range on average. So why is this important? We wanted to be able to help people plan for when they're traveling or using their EV and how often they should stop, depending upon the temperatures that they might be experiencing at that time. So that was the purpose of this particular study. The next, we did EV range validation compared to EPA estimates. So folks were coming out with estimates on how long the EV could go, and basically our goal here was to validate that data. So among 4 vehicles evaluated in 2020, AAA derived coast-down data specified an average of 6% more applied force over a range of 10 to 75 miles per hour. For EVs subjected to dynamometer testing using AAA-derived coast-down coefficients, a 19% decrease in combined driving range relative to EPA estimates was observed. AAA continues to advocate for rigorous testing standards that better reflect what customers can expect to observe in terms of driving range and efficiency. We have shared our data with the EPA, and they are revisiting it at this time. So we just want to make sure that the public is fully aware about what the vehicles can do. And then I mentioned ADAS. And ADAS is important because ADAS is a part of every EV vehicle. So every EV vehicle has some sort of automated driver assist system embedded in it. And the current vehicles that are on the road today also have ADAS in them. So these systems have great potential, and AAA is certainly backing them 100%. But we also want people to understand what their limits are and how to use them. So our testing not only includes automatic emergency braking, we test adaptive cruise control, lane keep assist, blind spot monitoring, and our goal continues here to learn and share data with the general public and the industry, including OEMs and engineers, so that basically we can make sure that these vehicles are being used properly on the road and that they're safe. The other thing that we want to do is make sure that we have the training available to all in the field. So automotive technicians and those on the roadside can also understand the limitations of these vehicles. And as you can see here, one of the tests we did, this was the photo there is of an intersection where a vehicle is crossing the path of a vehicle with ADAS technology and automatic emergency braking. And as you can see in that scenario, it didn't work so well. But this just gives you an idea of some of the other testing that AAA is doing. And we are sharing this information with stakeholders so that they can understand what they need to continue to do in the future. And basically, that's it for my presentation. So I just wanted to let everyone know that AAA is in this space. We're working to help educate the public. We're working to bring folks together as we are today so that we can collaborate and make sure that these systems are being used properly and safely on the road today. Thank you.
Our next speaker is John Steckinger. John is president and CEO of Independent Truck Repair Group. He has been in the industry for almost 30 years, working for companies like Volvo Truck. He has his MBA from Gothenburg University in Sweden. His success includes increasing the network from 10 million to 600 million in purchasing revenue and starting a network for truck OEM dealers. He started the Independent Truck Repair Group in 2017, which has expanded to more than 200 members, primarily focused in training, consulting, and national programs, and it's growing. Welcome, John.
Thank you very much. Before I get into the background and overview of our company and what we do and how we do things, I thought I'd share with you all a video of how we conduct our training, how we develop our training. So I'm not sure who I point to. Who do I point to? Just point.
to Electrified Propulsion Vehicle Safety Training. This course is designed to provide you with the necessary experience to become an electrically aware person, as you interact with electrified vehicles of all types in the workplace.
I wanted to provide the video to you first before I got into my presentation, just kind of give you a brief overview of how we develop our training and what our network is. Again, I'm John with the Independent Truck Repair Group. I'm the president and CEO, and we have 500 plus locations around the U.S. that have independent truck repair shops that are part of our entity. What that means is they get involved in our national programs, they get involved in our training, which goes not only to our owners of the company, but also to the technicians. And we train over 1,500 technicians a year, primarily in wheel end, suspension. We train in after-treatment DEF, but also electrical. And electrical training is our #1 required or requested course in the U.S. today. And quite frankly, I think we have the best electrical training in the country. But that being said, about 2 years ago, we saw a rapid expansion, in my opinion, of electric vehicles start entering the space. Look, our network and who we deal with don't change the market. We don't set up the market. We don't start the market. Our guys, basically, we just adapt to it. So when we start seeing vehicles that come into our shops, again, we have over 500 locations. We're running about 720 million in ROs or repair orders through our network every year. So what has happened the last couple of years? We're starting to see EV vehicles come through our shops. The OEs have developed this. OEs are terrific. The problem is they don't give any training or provide the training to the independent market so that we can understand what the heck's going on in the vehicle. And that's an issue. So what we had to sit down and basically put together is how do we get the training to our technicians? Electrical is electrical at the end of the day. I don't care if it's electrical on a combustible engine or if it's on an EV vehicle. You're going to utilize the same tools, a multimeter, oscilloscope, et cetera, to identify and understand what those problems are in the vehicle. So that's what we've done. So 2 years ago, we sat back at a board meeting and said, what is the #1 issue in front of you today? Outside of it, you can't find technicians today. The second one, or at least 1B, was please provide us the best training on EV vehicle. We see it coming through the shop. How do we work on it? How do we set it up? I mean, right now you have 60% less parts on that vehicle when it's an EV vehicle. What's the tools that I use in the shop to work on that specific vehicle? No one knows. Well, they know, but how you set up the shop. We don't have an engine, we don't have a transmission. But what we can do is we can get into the electrical side. Today, for every 10 technicians that you see, 2 technicians are qualified in electrical vehicle. They're qualified to work electrically on a vehicle, 2 out of 10. So now we're going to move into this space with EV vehicles. We're going to have roughly 25 or 30 million vehicles in the market by 2030, and our technicians are not properly trained. So that's what we do. So we get into that type of training. We're setting up the training today, not only in the EV side, but EV 101, how to set up your shop. We're also going to sit into safety, which is the #1 requested. What are the things you need to look at? And lastly, and in conclusion, one of the other things is, I think we touched on it this morning, is fire. What happens when the vehicle explodes? When it's sitting underwater, especially an issue we saw down in Naples, Florida, I think if you may remember last year, it was all over the news. What happens with that vehicle? Can you put it out with a fire extinguisher? The answer is no. So do you have the proper suppression, not extinguishing? Do you have the proper suppression? And we've developed and working with a supplier today in putting that together. So this is a very important area for us. EV vehicle, as it expands, is an important area for us as we expand into the aftermarket, the independent aftermarket. We're also not only touching truck and medium light duty, but we're also touching automotive. We think that's very important as well. At the end of the day, it's electrical. It can be on the automotive side, the heavy duty side. That's where our training needs to be. 'Cause, 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 I guess in closing, one of the things we're also getting into, which is the reason I'm very excited about being here, is not only training with our technicians, but as we move into the schools, the different types of trade schools, and how they bring their students out, they really need to have this type of training when they go out as well. So we're excited about working with Owens and Owens College along with Bob, and then not only exposing our training to the technicians, but to the trade schools as well. Thank you very much for your time. I'm looking forward to any questions later on this afternoon or this morning.
Thank you very much, John. And our final speaker for today is Santos Ramos. He is the project manager for Drive Ohio. It's an initiative of the Ohio Department of Transportation that serves as the state's hub for smart mobility on the ground and in the air. Prior to joining the state of Ohio, he gained diverse experience as a civil engineer in the private sector, working on alternative project delivery, smart cities, and transportation electrification projects across the country. His primary focus is helping the state of Ohio successfully implement the NEV formula program and other EV-related initiatives. Welcome.
Good morning, everyone. Thank you. Last one here. I don't want to be a bottleneck for all the questions you guys might have here. So right off the bat, a little bit of, let's see here. So I'm going to be talking about our efforts. There it is. So thank you, Lisa, for the introduction. On behalf of ODOT Director Marchbanks and Executive Director Drive Ohio's Executive Director Preeti Chowdhury, just want to give a thanks to AAA and Team ACOG and Owens College and all other partners here today. Thank you for the invite, and we're excited to kind of share a little bit on our efforts on transportation electrification. So talk a little bit about Drive Ohio and what it is, our past and current EV-related efforts, and then some Ohio market trends that we're sort of tracking as part of our efforts to implement some of the EV charging infrastructure through the NEVI formula program. So what is Drive Ohio? Right? So Drive Ohio, like Lisa mentioned, was an initiative. It's an initiative that was developed through executive order back in 2018. From the Ohio Department of and it's a division of the Ohio Department of Transportation. We focus again on smart mobility technologies and trying to bring the technologies to Ohio and test them by and focusing on increasing safety, enhancing mobility, expanding access, and preparing the future talent of Ohio here. So. Alrighty, so I can, like I said, dig into it. Some of our past EV-related efforts, Drive Ohio has been working on transportation electrification dating back to 2019, so this is all pre-NEVI. In 2020, we released a report that assessed the EV needs of Ohio's interstates, and then also identified gaps and provided strategies and recommendations for other stakeholders around the state on how to address them. The study was, like I mentioned, done pre-NEVI, so when the NEVI formula funds came around, it was actually like a great starting point for us, and we were able to sort of hit the ground running and have an idea. At that time, we also engaged with a lot of our utilities, so they had vetted out a lot of these locations in the 2020 study to see if there was three-phase power availability and, you know, if there would be any capacity concerns at some of these primary locations along the corridors. So that kind of, and I'll talk about it later, but that kind of set us a little bit ahead of the stage, which we were able to come out with an RFP, be the first state out there to come out with an RFP when the NEVI funds came out, and then we were the second state to announce awards after that. So in 2021, the EV charging infrastructure planning efforts did not stop. Drive Ohio continued to push forward and release the freight electrification study. This study, again, focused and summarized Ohio's landscape in the last mile medium-duty and heavy-duty electric vehicle market, and it also provided and identified a couple of actions that Ohio stakeholders could do to help facilitate the transition into EVs. And then finally, through a partnership with the Ohio Bureau of Motor Vehicles, we have a live alternative fuel vehicle registration dashboard on our website. It's open to the public. That data is updated monthly, and it provides all of the alternative fuel vehicle registrations dating back all the way to 2019. With that said, I'll jump into some market, trends that we've noticed through this dashboard that I'm talking about. As of August of this year, we've had 15,600 new alternative fuel vehicle registrations in the state of Ohio. We're still, 4 months before 3 months before the year ends, and we're almost going to reach last year's goal there. Number of vehicle registrations. So, I think this is a good thing. It shows that adoption, is still strong. It's increasing. You can see 2019, we only had about 6,000. Both 2019 and 2020, we only had about 6,000 alternative fuel vehicle registrations in the state, and it's more than doubled by now. So I think it's kind of exciting. I do want to mention that alternative fuel vehicles registrations include full battery electric vehicles, plug-in hybrids, fuel cells, and CNGs. So breaking it down by region, here we can see that the 3 Cs, pressing the wrong button, there you go. You can tell I'm not nervous, right? Like I mentioned, here now you can see that the 3 Cs kind of lead the pack here on alternative fuel vehicle registrations. We have over 12,000 in both in the 3 Cincinnati, Columbus, and Cleveland area. Toledo, that only has about 2,600, but still going strong. I do want to say as of August of this year, we have 57,134 alternative fuel vehicles registered. 99.8% of those are either full battery electric or plug-in hybrids. And these are the top EV models in the state of Ohio. You can see Tesla, both Model 3 and Model Y leading the pack there. Chevy Bolt, that's the Bolt, so that's the plug-in hybrid, not the actual Bolt that just came out a couple years ago. And then Tesla again taking the number 4 spot there, and the Jeep Wrangler plug-in hybrid, which is actually surprising. Yeah, and it's very nice looking too. And I'm not sure on the range that you get on plug-in hybrids. Anybody drive a Jeep Wrangler here? Plug-in hybrid? It's about 40 miles. Okay, right. Thanks. 40 miles. So I'm not gonna, Brian touched on a lot of this already, but I do want to just mention or focus a little bit more on Ohio specific. We've received $140 million for this formula program. We're going to be getting them, they're going to be dispersed over the next 5 years. We've already gotten, the first 2 years. We're using that money right now to build our alternative fuel corridors, and I'll explain a little bit more what the alternative fuel corridors are. And like Ryan mentioned earlier too, the private industry with this program, they have some skin in the game. It's an 80-20 funding split. When I go into details of our first round of procurement, I can share that. I'll share some interesting facts there. And then the CFI grants, the charging and fueling infrastructure discretionary grants, split into 2 buckets. Half of it will go into charging and fueling, alternative fuel corridors. And it's kind of like just to build redundancy. There are also less stringent requirements on the amount of power that you have to comply with. And then the community charging, the other half, the other $1.25 billion, it's going to open up over the next 5 years as well for community charging. So again, there was a couple of applications this past round. I know NOACA in Northeast Ohio, the MPO there, had a good one, and there was also coalitions down in Southeast Ohio coming together and putting an application for that as well. So, alrighty, so I talked about alternative fuel corridors. Alternative fuel corridors are, it was a program that was implemented by FHWA about 7 years ago. This is all way pre-NEVI. Nobody, they were just kind of doing their own thing and they didn't really know what was going on. So you could nominate corridors. Anybody, any public agency could pretty much nominate corridors. A lot of the efforts for Ohio's corridors were actually lifted by MPOs and local or regional planning organization as well. So once NEVI came around, FHWA was like, oh, let's just take this program and, we'll make this the guidance and we'll say that they have to build out the interstates and all of the alternative fuel corridors. So prior to NEVI, we had designated electric vehicle corridors all across Ohio, and a total of them was 16 of them. You can see that all the major interstates are there, all 3-digit interstates are there, and then there's also a couple of U.S. and state routes. Brian kind of covered this, so you guys are aware. DC Fast, level 1, level 2, and DC Fast charging. Type of connectors down there, we have CCS, Chatham and NACS. If y'all have been following the news, a lot of the OEMs here in the United States are going to adopt the NACS connector. It's the North American Charging Standard. It's actually not a standard. Funny story. So Tesla just decided to call it a standard. So I guess they get to do what they want. But they're claiming it now, and it's actually it's a good move, I think, for the industry. We're trying to get some standardization and making sure that all chargers eventually, will be able to plug in the same type of vehicle. So. The criteria for the NEVI program to build out the alternative fuel corridors, we have to meet specific criteria. Once we meet that, then whatever money's left over we can use in a discretionary way. However, the requirements for the charging stations that we're supposed to build along AFCs are actually pretty stringent. We have to have charging station every 50 miles. They have to be within 1 mile of the corridor. It has to have 4 DC ports, have to be CCS for now. This is a very dynamic program. Rules keep coming out every summer pretty much. This past summer we had a new guidance that, added a 25-mile rule where AFCs terminate. So they call it a 25 termini rule. And so that kind of shifted a little bit of our procurement strategy and added more locations to interstates. We thought we were going to be done with interstates by round 1 of procurement, but unfortunately, due to that rule, now we have to add a couple more, especially on those 3-digit interstates. And then each port has to at least provide 150 kilowatts of power, and therefore, a total power for a station has to be at least 600 kilowatts. So the 16 EV AFCs make up 1,867 total miles. Along those miles, there's 13 NEVI compliant stations. These were built pre-NEVI. The majority of those are actually Electrify America. Electrify America was a division, I don't want to say company that came out of the Dieselgate scandal from VW. So they've been implementing electric vehicle charging stations that meet NEVI requirements. They supply 150 kilowatts or more sometimes. and meet the whole 1 mile from the interstate and things like that. So these 13 stations right now are NEVI compliant, and we're using those as we plan and move forward with how we're going to be using the funding. So again, just a map outlining the 13 NEVI compliant DCFCs that we currently have in the state of Ohio. And then this is a little busy. Ryan showed it earlier too, but I'll try to do my best. And I can also answer any questions once I'm done here. But the light blue dots symbolize the 27 contingent award locations that we came out and announced this past summer. We, again, as I mentioned, our first round focused on building out the interstates. So those 27 locations will comply with the 50-mile requirements, et cetera, that I just talked about. And we should be able to build out all interstates with the 27 locations, except for those 3-digit, pretty much loops. So like 271, I think, no, that's 271. There's like, I think it's 275 in Cincinnati, that because of this 25 termini rule, we have to add a couple locations, so that's going to be coming out in our second round. Also, the 3-digit interstate over there by Youngstown, is it 670 or something like that? It's also going to be, we also had to add it, due to these changing rules. So, with that said, the darker blue are the potential locations that are going to go out in our second round of procurement, where private industry is going to be able to bid and they're going to bid for, and we're going to go through our procurement process and score and evaluate and try to pick out the best locations among those specific areas. That round 2 should help us reach full build out. So we're hopeful that we're going to get the same amount of industry engagement that we got in procurement and the first round of procurement, so we can try it and get that built out certification from FHWA. And then if we're able to get that certification from FHWA, we'll be able to use our remaining funds in a discretionary way, where we can sort of start focusing on the gaps around the state. So those potential locations or anticipated locations can be shown with the red dots. You can sort of see there's a couple charging deserts out there. So a little bit about our first round of procurement. Proposers were primarily EVSE vendors and fueling stations. We did have one general consultant that was representing some of their clients and submitted 125 bids. So it's important to note the bids where we put out a list of general locations, and then private industry took a look at those, and then they suggested actual private locations within our areas and as a potential location for implementing and deploying the charging station. So we got 300 side proposals, 30 different teams, and the goal was to select a successful proposer for each corridor group, or the 30 stations that we went out there with. Unfortunately, there was a couple of groups out there or locations out there that we weren't able to get sufficient competitiveness on. So we announced the 27 contingent awards in mid-July, and after doing some analysis, we did confirm that those 27 locations will be just fine, and we'll be able to build out the interstates with this first round. Round 2, again, is going to keep focusing on alternative fuel corridor build-out, but it's going to be mainly on U.S. and state routes and the couple of 3-digit interstates that I've been talking about. And we're hoping to release that RFP by the end of this year, but later this fall. And this is just an anticipated deployment timeline. We're hoping that we can have most of these stations up and running by the end of 2024 on the interstates, so the ones that we just announced this summer. Then we're hoping that we can make some sort of announcement late spring of next year, and then start construction on those fall or winter of 2024, and have those built out by 2026. If so, we'll be able to again get that FHWA fully built out certification, and with that certification, then we'll be able to use the remaining funds on a discretionary way, and we'll have rounds 3 and 4 and possibly 5. It really depends how fast we can move here. But we're trying. We're a small and mighty team. It's pretty much just 2 of us working on the program full time, and it's $140 million, so it's a big task there. And then on top of that, there's also annual plan updates that we have to send in to the Joint Office of Energy and Transportation, and we have to explain how we're going to be using the funds. And there's a lot of stakeholder involvement, and it's been busy, to say the least. And then, just wanted to highlight that we have a lot of good resources on our website for communities that are interested in applying to the CFI grants. There you go. Yeah, so we have a lot of good resources on our website for communities and other organizations that might be interested, public entities that might be interested in applying for CFI grants. We have I'll stick around if anybody has questions on what kind of resources, but we have guidelines and best practices and grant writing tips and whatnot. So, and then lastly, I do want to mention that due to the major transition and investment on EV-related industries, Ohio has developed an electric vehicle workforce strategy. The plan focuses on strengthening and building Ohio's advanced manufacturing workforce specific to the EV transition. The strategy was actually developed by the Governor's Office of Workforce Transformation and the Ohio Manufacturers Association. Drive Ohio is happy to be helping. We're supporting this initiative by we provided an educator toolkit to support K through 12 and STEM education, career outreach programs, and the toolkit also includes a free curriculum and professional development and career connections for teachers out there. More information can be found at drive.ohio.gov, and then also more information on the actual strategy and the EV workforce aspect of this at workforce.ohio.gov/EV. And there you go. That's it. Thank you very much for your time. Appreciate it.
Thank you. Such an impressive lineup of panelists, a lot of brain power in this room. So make sure you take advantage of it here in a few minutes. We're going to take a very quick break, about 5 minutes, and we're going to transition to the panel discussion. And remember, you're going to have the opportunity to ask questions. You can submit a question if you'd like on the cards that are provided, or you can step up to the mic and ask a question. But wow, a lot of layers of information in this room. Take advantage of it. We'll be right back. Yes, it's extremely dark back here. But that's why it's important to have the lights on the phones. All right, I think just probably just like 5 minutes, I thought, for that, because
Yeah, we're running late, a little behind.
introduction for me?
Nope.
And how do I say his name? Gideon? Is this Dave?
Yep.
Gideon?
Yep.
I think I've interviewed you before.
You have.
But I was like, wait a minute, I'm pretty sure I've interviewed you before. He's familiar.
And you've also moderated our transportation
Yes,
summits in the
yes.
past too, so
Yep.
the table over, I'm not sure that's.
You know, I need my, Yep.
Is that where I ended it?
Yep.
I'm sorry. Team Cup.
Yeah, I don't have anything, so we'll just have to. I don't think people really use intros. I know they do them.
Are these the chairs?
Just bring my chair from the side. I'll bring mine from over here. I laughed when you walked back there and you're like, wow, it's really dark back there. It is really dark back there. I have not either. As many times as I've been here to campus, I have.
Welcome back, everyone, and we're going to start out by opening it up to questions. With all that knowledge that we just had presented to us, there should be some questions, so feel free to stand up and ask away. And you can come right to the microphone here, yes.
Well, thank you. Thank you for the opportunity to ask a question, and thanks for the information that was provided this morning. So I'll allude to the, and I'll give a quick disclaimer. I am that NASCAR guy that likes to NASCAR pit stop quickly. In understanding that EV is ever evolving, particularly in Ohio, as we just discussed, as a family that likes to travel, do we know if any of the other states that are surrounding, primarily those travel corridors such as 75, 77, I-80 that was in the slide, are those other states somewhat similar to Ohio? Is it, I mean, it's something that we have to have some care about now if we were to purchase an EV and I want to travel with my family, do I have to call, AAA if we get stuck, to come get us, or how's that working out?
Lisa, I can actually take that question. So the answer to your question is yes, other states are working at producing the same programs. The state of Ohio is ahead of many other states right now, but other states are catching up quickly. And AAA is working with other companies. There are several companies right now that are producing, on their apps, places that where there's a charger and if the charger is available. I was just in a meeting yesterday where we were talking about that ourselves, making sure that when folks go onto our app, for example, you can tell if a charger is available or not, and if it's working, right? So that's another concern. But I do believe that you are going to have the infrastructure that you need to travel. Our recommendation, though, at this point is to just make sure you plan.
Bob, can I follow that up?
Sure.
It's hot.
Okay. So another consideration with that is, as Bob mentioned, planning is key. There are a lot of apps out there that will let you know where charger locations are and what the availability is. Ohio is leading the way in terms of the NEVI programs, but there's a lot of private investment in charging infrastructure that's out there. But really there's two routes. Tesla vehicles have built in into their navigation where it actually will plan your charging route just by simply putting into the navigation. So it's a little less effort, and they do have one of the largest charging networks available today. If you are going to be charging under the CCS standard, though, at least as of today, there's just that additional step of planning, but there's a lot of charger availability. Personally, I have not noticed anywhere that I've been unable to travel from my anecdotal personal experience. But, yeah.
And then just to add too, so I mentioned a little bit about the fact that every year we have to update a NEVI plan, and we have to submit that to the FHWA and the Joint Office, and they review. And it's essentially a plan on how we're going to be using our funds for the next fiscal year. And part of that, updating that plan, is engaging with our neighboring states. So we're in constant communication with our neighboring states and trying to figure out, where placing locations make the most sense. A good example that I can give you right now is I-76, the Turnpike on its border with Pennsylvania. The Turnpike does not accept federal funds, so we're trying. We can't deploy NEVI. We can't give them money to deploy NEVI stations. So we're in constant communication with them, trying to inform them of our requirements and what we need to be able to build out and get this certification. And our neighbors on Pierre also made their own analysis, and they realized that to meet the 50-mile requirement, there's really no exits along the I-76 stretch on their end until you kind of get to Pittsburgh. So something we're constantly working through and talking with our neighboring states and other partners as well.
Thank you. Next question.
Hello.
Thank you for the presentations. They were great. And I also work for First Energy, Toledo Edison. So hi, Ryan. But my questions are going to be a little bit niche because of that. So my first question, it looks like you guys have already partially answered it. In the event of a power outage on a public EV charging station, it sounds like that station would be shown on an app or something of that nature as being unavailable. Is that correct?
Yes, a lot of it is dependent on user reporting. So if users are reporting that hey, the station is unavailable, that's kind of highly dependent on that. I believe the Tesla supercharging network is built off of telemetrics. So if they have a communication feature that is sent to Tesla to let them know that the station has lost power. Now, I'm not as familiar with some of the other ones like ChargePoint or Electrify America. They may have a similar system as well, but a lot of the apps do kind of show the availability of that, how many stations are there, how many are available, and whether or not they're operational. Any other?
Awesome. So I guess the next part of that question is, and this is partially for First Energy, because I want to hear what First Energy's response is, but also from the professional EV group up here. In the event of large spread power outages or an event such as, you know, a storm that rolls through an area, would we as First Energy, and is there push from the EV community to make EV public charging stations a higher priority for restoration over other items?
So I think it already kind of, our restoration policy already kind of naturally lends to that. So our restoration policy is basically focused on what's going to get the customer, like the most impact to the customers first. So that's going to be along the transmission restoration first. And a lot of these larger stations are going to be at a larger like feeder level, and those outages are going to be caused usually by high voltage transmission outages or sub-transmission outages, which are naturally targeted first. So through restoration, we don't really have to much change our policy to make sure that they're up and running quickly.
And then I guess my last question is extremely niche.
Yeah,
So,
all right.
and I'm probably going to look at the AAA for this one. So, one of the events that happens in the utility industry that's very unfortunate, but it's quite dangerous, is what we have actually acronymed a CFPA, which is a carpool accident. It's where a car comes into contact with an electrical pole, and the lines tend to, fall on the vehicle in this very unfortunate accident. Our guidance for, I actually do some of the training for our first responders and public in that scenario. And for a normal combustion engine car, we typically tell the individual and the people that are responding to the incident to keep the individual inside the car as long as possible to keep them safe, unless the car, combusts, catches on fire. Is that what you would feel to be a correct approach even with EVs?
So from our approach, yes, it would be the same. And, again, to your point, I think it's certainly commendable what you're doing as far as that training is concerned, because that is a big concern for us, not only as it relates to first responders, but as it relates to roadside. And then also as it relates to auto repair shops. So, and then that's where John comes in. I don't know if he has any comments on it.
Excuse me, that's a good point. One of the things we're also working on within our training side, I guess a couple things to that is for municipalities on both police and fire. We're talking about charging stations, where to find them, application apps to go find them. This is very typical, and it's not condescending by any means, but we just forgot about service. So car broke down. Is there also an app that can find where is an approved location to fix my vehicle? So I think those need to be kind of put together, but that's a great point. The answer is yes, we're coming out with those type of training modules specifically for what you're talking about.
Thank you for the questions.
Thank you. Good questions. Come on up, Edgar.
Well, this question is for First Energy, and I'm not with First Energy, by the way. I guess my question for Ryan is, what type of investments will First Energy need to make to ensure that you have the capacity to service the tens of thousands of charging stations that will be built over the next 10 to 15 years? And do you see any issues with your capacity to do that?
Yeah. So, great question. Thank you, by the way. Right now, our traditional capital plans look at kind of like a 3 to 5 year window, and we've kind of identified, at least within that window, that we don't expect any major impact from transportation electrification. Now there's going to be individual circuits, little niches here and there that are going to need to be addressed, but it's not thing that outside of our current new service upgrade process that we shouldn't be able to handle. Now when we get beyond that 5-year timeline, that's when we really start to see this kind of hockey stick growth pattern and adoption with electric vehicles. And right now we're currently looking at a various suite of planning tools that we can integrate into our distribution and transmission planning. I'm actually heading up a team that's going to be the transportation electrification infrastructure planning team, and that's the exact kind of question that we're looking to address. So there are various suites out there of transportation, like PhDs and experts in the transportation space that understand where these vehicles are located and how are they used. Now as a utility, we know a lot about our customers. We know a lot about their electrical usage, but we never really had the need to understand, okay, what vehicles do they have and how do they use them? That's been outside of our wheelhouse, no pun intended. But now that's something we're actively looking to get insight into, and there's some impressive things that the Electric Power Research Institute, or EPRI, is putting together, where they're creating heat maps on where the potential for electrification adoption are, and they provide this down to a granularity where we could get it into the feeder level. Anecdotally, they show, here's an industrial park, there's a chemical manufacturer there's a distribution, like a logistics company there, and in another vendor that, they have like all fleets of trucks. They all decide to electrify, that's going to go from somewhere that, okay, they maybe had 3 warehouses where between the 3 of them, they had maybe, like 1,000 to like 1,500 amps of service, and now all of a sudden they're looking at increasing 100-fold. So we're actively looking at the biggest problem for us is trying to predict and identify, because we don't want to build bridges to nowhere by building out this great infrastructure for nothing to materialize. We have to be prudent with our resources, but at the same time, if we're not proactive about it and we don't plan accordingly for this infrastructure, then it ends up being more costly, because then we have to be reactive and kind of playing catch up, and that is costly in its own regard. So very difficult problem to approach, but it is something that we're actively engaging in, and hopefully within the next year or two we have a solid plan to address exactly that.
Thank you. And a question that came in earlier, and you touched on a little bit, Dr. Mubenga, but have there been any breakthroughs in battery recycling that will lessen the concern of, the impact on landfills?
Thank you for the question. So lithium-ion battery recycling, I believe that question is more for lithium-ion, right? Because lead-acid batteries are being recycled at the rate of 99% right now. So I think we are pretty good when it comes to lead-acid battery. When it comes to lithium-ion battery, there's a difficulty with recycling. People like lithium-ion battery because they have the highest energy density, meaning that in a small volume of lithium-ion battery, you can store a big quantity of energy compared to other batteries. But that capacity of storing a big amount of energy, that high energy density, it's because of the electrolyte inside the battery, which is the liquid that allows the chemical reaction. That electrolyte is very volatile. And as a result, the recycling process for lithium-ion battery is difficult also because of the components that are in the lithium-ion battery. The other aspect also is, like I mentioned earlier, is that most of those components are, like nickel, manganese, cobalt. You have a lot of rare earth minerals. So there are two processes right now to recycle those lithium-ion batteries. There is a process that uses high temperature, and there is where you basically burn the batteries until they melt, into a black powder. And from that black powder, you can recover the specific rare earth material, such as cobalt, etc. That's very efficient when it comes to cobalt, recycled cobalt, but for lithium, it's actually cheaper to mine lithium than it is to recycle it. So you have some difficulty when it comes to recycling. The other type of recycling is a liquid process where you basically melt the battery in some type of liquid and then you kind of extract the material from it. So right now, there's still a lot of research. In the US, we still have a lot to do for that, for recycling, but in Canada, they have advanced a lot when it comes to recycling lithium-ion battery, and they even have a program in their, I think it's with the regulator, they have some type of program for lithium-ion battery recycling. So I think it's possible, like I said, because it's already done in other parts of the world. We just need to, I guess, put more resources into that recycling path. For some reason, it doesn't seem to be a high priority right now. As I mentioned, in the circular economy of battery, right now I feel that people are not really looking into the recycling or the second life application. We are, we have to keep in mind that EVs are fairly new. It's a fairly new technology, so it has to age, and then it has to mature, and then it can be put into place correctly. So I think we are making progress in that sense.
Thank you so much. So many questions, but we are going to wrap it up for now. We'd like to thank you for attending today in person or if you're attending virtually. And you'll be able to view a recording of the seminar on the AAA Club Alliance YouTube channel. Really an impressive lineup on this stage, and so take advantage of it. I'd also like to thank Owens Community College and the Toledo Metropolitan Area Council of Governments for their support of today's event. I'd like to thank each and every one of these panelists. How lucky we are to have them all here with us and to be able to ask these questions. And I got a few story ideas today, so I will be asking them more questions as we move forward. I'd like now to introduce to you David Gideon, the Vice President of Transportation with TMACOG, with a few closing remarks.
All right, why don't we give Lisa a big round of applause for the work that she's done today. Lisa's a professional in the truest sense of the word, so as noted before, she's been involved in all of the Technology Takes the Wheel events that have taken place since 2018, so truly dedicated to the work that we're doing here. I want to thank all of you for attending. I want to thank everyone that's attended virtually. I want to thank all of our presenters. Fantastic information, diversity of information. And as Lisa said, she's got some stories she can take back and develop for future news stories, so that's a benefit as well. Real quickly, Santos had mentioned the EV study that Drive Ohio did, the statewide EV study. TMACOG is going to be undertaking a Northwest Ohio EV study in the coming weeks, hopefully. We're just waiting for a notice to proceed on the study. So once we get that, we're going to develop a charging study that will look at Monroe County, Lucas, Wood, Ottawa, and Sandusky counties. So we want to try to get a sense of, make recommendations on where chargers ought to be located, what type of chargers are required, whether they're level 2, level 3, how many ports, and give communities information on, put together a toolkit you can use for applying for grants, where to go to, what information to provide, and give you some of the information that you could actually plug in the application. So we hope to be kicking that off in the next few weeks, so be looking for that. But Want to thank all of you for attending. Drive safe, and we'll see you at the next Technology Takes the Wheel event. Thank you.